In this video, we're going to create another class of our own called course. And this course is going to represent a group of students that are taking a course together. So again, you could think of a lot of things that we could use to describe a course, but we're going to keep it pretty simple, and we're going to describe a course by the title of the course, the number of students enrolled, the maximum number of students that can be enrolled, and the list of students. Okay, so again, we'll think about our instance data variables first. So I'm going to have a name of the course. I'm going to have a number of students enrolled and a max enrollment. And I'm going to have a list of students. Now, there are lots of different ways we can keep the list of students that are enrolled in our course. We could use an array. That would be an obvious choice. We could use a student array called maybe students to keep track of things. This is one option. I'm going to strongly encourage you, especially if you're a little bit rusty in the material that you should have coming into this class, to rewrite this course using an array, because I'm not going to use an array right now because I want to use this class as an example of using generics with Java provided collection classes. So instead of using an array, I'm going to use the Java provided class called ArrayList. But you should be able to write this class using an array and using an ArrayList. Okay, so if you are not sure how you would do this with using an array, I strongly encourage you to write that code. I welcome you to share it on the discussion board, and I also welcome you to post questions about how you would implement the methods we're going to talk about with an array, how you'd implement the methods we're going to talk about using an array. So if you're not sure how you would do that, please post those questions, because again, this is something that I do expect you to know, but it's not something I'm going to do in this particular video. Okay, so instead of using an array, I'm going to use an array list. And we're going to start without using generics, and then we're going to add generics back in so you can see the benefits of being able to use generics in your programming. So to use the array list, I have to import it from the java.util package. Okay, so there's my instance data variables. We've got the name of the course, some information about enrollment, and the list of students enrolled. Okay, so next up is my constructor. So I might create a course by you telling me the name of the course. Probably always the number enrolled is going to start at 0. You might have a different program where you're going to load in classes that already have an enrollment, at which point you'd want to provide a way to specify the initial number of students enrolled. But for this example, we're just going to look at creating classes from scratch. So the number enrolled is always going to be 0, so I'm not going to take that in as a parameter. I will take in the max enrollment. And then because initially there are no students enrolled, you don't need to pass me in an existing list. I'm going to create that list from scratch. So again, this is a very narrow example of a course, and certainly there are more robust classes, I should say, that we could write. Okay, so in my constructor, I'm going to initialize all of my instance data variables. So course name is going to get the name you passed in as a parameter. Number enrolled is going to be initialized to 0. Max enrollment is going to be passed in the number that you passed in as a parameter. And then students is going to be initialized as a new array list. Okay, so there is my constructor. Now I'm going to go through and create my getters and setters, which actually I will show you a shortcut. So if you're using Eclipse, there's a shortcut in the source menu called Generate Getters and Setters, and you can select the variables that you want to have getters and setters for, and it will automatically create them for you. Now, if you use this shortcut, you must go through and review them, because what it won't do is it won't put in any validity checks. So for example, all right, for a getter and setter for course name, we don't need to really change anything. That's pretty straightforward. For the getter and setter for the number enrolled, if we want to set the number enrolled, we don't want this to be able to be a negative number, for example. So we would have to put some validity checks on that. But actually, if we think about it, I'm going to include an add student method, so a way for another user to add a student to this course. But if that's what they're going to do, then maybe I don't want to give them a way to directly set the number of enrolled students at all, right? Maybe that number is only changed by adding and removing students from the class. So I might decide I don't even want this setter, okay? So I'm just going to get rid of it. For max enrollment, getter looks good, but for the setter here, I do want to make sure that the number you give me is at least greater than or equal to 1, right? You have to maybe at least allow one kid in your class, or else what's the point in creating this course? So again, I can automatically create my getters and setters, but I have to go through and make sure that they all make sense. And then for my array list, perhaps I don't want to, again, provide a way to just directly set the array list to a new value, but I only want this list to be changed by enrolling and dropping students from the class. So I'm going to get rid of that method. And perhaps I want to be able to return an array list, but I might want to return a raw array, which if I did that, I'd have to do some modification to this method as well. So we can think about that. But this is a nice little shortcut to save you some typing, but don't rely on it without then going through each pair of getter and setter and making sure that it makes sense for that variable. Okay, so we've got the instance data variables, we've got our constructor, getters and setters. Next up is the toString. And for my toString method for the text representation of a course, I'm just going to return the name of the course plus, let's say, number enrolled. So that would be, for example, 3 out of plus max enrollment, spots filled. Something like that. That's going to be my text representation. Now, obviously, you might want to have a text representation that included the list of students, so actually printing out a roster, for example, and we can think about that. But for right now, we're just going to keep it simple and just have that. So these are my basic building blocks. I'm going to skip the equals method for now, but you would, if you were writing a full course class, you would want to include an overridden equals method. Okay, so these are my basic building blocks, and now I can go ahead and add in methods that make sense for this class. So for example, I want to add a way for someone to add a student or enroll a student and to remove a student from the class. So first of all, what I can do is I can take a look at the methods provided to me in the Java Array List class by searching for the Array List API and then taking a look at that. And here I can see all of the methods that Java gives me. So it gives me some add methods, gives me some remove methods, gives me a method called size that gives me the number of elements in my list. It gives me a method called toArray that returns just an array representation of my list, which that'd be great. If we talked about perhaps in our getter method returning an array rather than an array list. So it gives me all sorts of methods here, a get method, etc. So I'm going to use those methods in writing my course class. So what I want to do is I want to add a method called enroll student. And in order to enroll a student, you need to give me some information. In particular, you need to give me the student that you want to enroll. Now, I should think a little bit about what the return type of this method should be. So it could be void, right? I just enrolled a student and I don't send you anything back. It could also be a Boolean, meaning I enroll a student and then I return some information about whether that enrollment was successful, true if it was and false if it wasn't. It could be an int. I enrolled a student and then I return to you the new number of students enrolled. All those would make sense. It could be an array of students, the new student roster. It could be an array list, the new student roster, right? So there's lots of different return types we could use. You'd have to decide what makes sense for the particular program that you're writing, okay? All of those would be good choices. I'm going to choose to return a Boolean, basically meaning I'm going to return to you true or false about whether or not your enroll was successful. Okay, so how do I know, how can I tell if I can properly enroll the student? Well, the first thing I need to do is I need to say, is the number that's enrolled less than the max enrollment? Because if it's not, I cannot enroll this student. So I'm just going to return false and not change the list at all. But if it is, so if there are still spaces available, what I'm going to do is I'm going to take my student list and I'm going to add in the student. Now, what I can also do is I can return, if I look back at my API, the add method in ArrayList actually also returns a Boolean, basically meaning whether or not the add was successful. Okay? So I can return that value. So if there's room in the class, I'll return whether or not the array list successfully added that student, which it always should unless something weird happens like you run out of space in your system or something like that. Okay. So that is my enroll student method. Okay. Now I can write some other methods, like, for example, public boolean is student enrolled. And again, you give me the student. And here I can just return whether that underlying student's array list, and I can use the contains method, whether it contains that student. Okay, so that's great. I can do things like I can write a method, drop student. And again, you give me the student. And what I will do is I will first find out if the student is enrolled. And if they're not enrolled, then the drop was not successful because they were never there to begin with. But if they are enrolled, I can again use the underlying remove method of ArrayList, which also returns a Boolean, and I can return that. So I can say, okay, if the students.remove is successful, I can go ahead and return that value, and then you'll know, okay? So this is an example, and we'll do this a lot throughout this course, of using one data type, in this case an array list, to implement another data type, in this case a course. And we use the methods of our underlying data type, which are things like add, contains, and remove, to implement our new data type with methods such as enroll, drop, and is enrolled. So we're using the underlying methods of one data type to implement another data type. And this is something, again, we'll do a lot in this course. So get used to kind of seeing this structure. Okay, so let's create another method called print roster. And what we want to do here is we want to just create some system.out.print lines to print out the students enrolled in the class. So what we want to do is we want to we can use a couple different ways to iterate through our array list. We can use a regular for loop. We can use an enhanced for loop. If you don't know the difference between a regular for loop and an enhanced for loop, please post that to the discussion board. You will be expected to be able to write both kinds of for loops, so make sure you know what the for loop and the enhanced, or sometimes called the for each loop, how they work. We can also use an iterator. So an iterator is a Java-provided method of iterating through any collection, and we'll talk about iterators a little bit later on in the course. So for right now, I'm just going to use a regular old for loop. And we can start our for loop at position 0 because our array list starts at position 0, which we can find out if we read the documentation provided in the API. And we know that it has, it goes up to size or also number enrolled. Although, what did we forget to do in our implementation methods? We forgot to update number enrolled. Perhaps you guys didn't forget to. You might have caught me on that. But I forgot to update number enrolled. So I'm going to go back to my methods here, and I'm going to say, if I'm enrolling a student, I'm going to update number enrolled. And if I'm dropping a student, I'm going to decrement number enrolled. Now, I should technically first get the value of this Boolean, and only if it's true, do the increment or the decrement. But just to make things quick, I'm going to leave this as is right now. So in my for loop, to go through my array list, I could use the size variable of my array list, or I could use number enrolled. Both kind of make sense, right? So I'm going to say for int I equals 0, while I is less than. I'm going to use number enrolled because that is the variable associated with my object. If everything is designed well, number enrolled should be the same as size, right? So if that's not the case, then I've got a problem with my underlying design. Okay. And then what I want to do is I want to print out that student. So what I want to do is I want to say, okay, well, that student, let's get that student from the list, and then print that out. Now, I'm getting an error. I'm getting an error because I have not used generics in defining my array list. I just said it was an array list. I didn't say what kind of object it could hold. That means that this list can hold anything. It can hold a student, it can hold an integer, it can hold a string, it can hold anything, okay? That is sometimes a good thing. There are maybe a handful of times when we want a collection to hold different types of things, but most of the time we want our collections to hold a single kind of object. In my case, I want this array list to hold students. I always want it to hold students. I don't want it to be able to hold integers or strings. I only want it to hold students. So what I can do is I can use generics to specify that. If I choose not to, if I keep it like this and I don't use generics, what I have to do is I have to cast the thing I take off my list to be of type student, because Java doesn't know what it is. It only knows that it's an object. It could be anything. And so it doesn't know what it is. So I have to cast it and tell it that it's a student. And really, if I want to be safe, what I should do is I should get an object from the list. I should make sure that that object is an instance of the student class to make sure that somewhere along the line something else didn't get added to my list, and then, only then, cast it. Okay? That's kind of a pain, right? And also, it doesn't really go along with the underlying design of my list in that I really only want students in my list. I don't want something else to accidentally be able to be added to my list. So what I should do is I should use generics. And to use generics, what we do is we put a type inside angle brackets specifying what can go into this collection. In our case, we're saying this array list can only hold students. Okay? And then I'm going to use that same syntax in my constructor, although now in the newer versions of Java, you can leave that out and you will still syntactically be okay. And now down in my roster, I don't have to do all this nonsense of casting and checking, because I know the only thing that's allowed to go inside this list is student objects. So I can safely get something out of that list, and I know it's going to be a student. So generics are great because they put a compile time check on the type of things that can be added to your list, meaning that nothing of the wrong type can accidentally be added. And they also then allow you not to have to cast when you get things off a list, because you know you were never allowed to put anything else on there in the first place. So this is kind of a silly example, but I would not be able to say students.add the string hello. If I try to have that, we'll get a compiler error saying, hey, you can't add a string to a list that holds students. And we always want to have our errors come up at compile time, because as much as you think it's a pain to fix things at compile time, it is a bajillion times easier than fixing them at runtime. And that is a mathematically proper term for the comparison of the difficulty. But seriously, we always want to have compile time errors to fix rather than runtime errors. So using generics allows us to put a compile time check on making sure that the right kind of object is always added to our lists, and then we don't need to use any casting when we get things out of our list, because we know that was the only type that was allowed to be added. Okay? So that is an example of using generics in a Java-provided collection. In the next video, we're going to look at using generics in collection classes we write ourselves. Okay? So we're going to look at that in a moment, but the simplest way to use generics is, again, with a Java-provided collection like an array list or a linked list. And this is how you do it. You just put the underlying data type in angle brackets, and then that is the only type that can be added to that list, and you know that it's the only type that can then be removed from that list as well. So this is an example of writing a class on our own, again, using generics, and also using one data type to implement another data type.